here in Denver, Colorado at the big 5G event, and today I'm joined by Yasir from A10 Networks. Yasir, thanks so much for making the time for us.
Thank you.
Well, it's great to see you.
So,
we're here talking about 5G and how networks are changing. How do mobile networks have to change in order to support 5G?
Keep in mind that 5G was devised and it was designed in a way that mobile networks or operators can introduce multiple use cases in a piecemeal fashion.
Right.
What does that mean? That means that some operators are choosing to monetize IoT or massive IoTs, others are focusing on fixed wireless and the mobile broadband type solutions and use cases. So with that in mind, it's a piecemeal modernization. And that means that mobile providers can choose to modernize, choose to have one idea, one use case in mind, and then they modernize, they monetize, and after that, once they're done, they move to the next one. And that's how I believe the 5G evolution will happen, that it won't be a big one event that everything moved from 4G to 5G, rather it will be a piecemeal introduction of multiple use cases over time. And that's what we seeing around the world as well.
Yeah.
Some countries are choosing to go after fixed wireless because of the last mile delivery problems.
Right.
Other countries are moving towards massive IoT because they already have a pretty good last mile delivery network. So that's what we're seeing around the world as well.
So even though we talk about it from a consumer side as going from 4G to 5G, service providers really don't have to rip out and rebuild their networks to get from one to the other. It's a gradual evolution as the use cases allow.
That is correct. That it's not a rip and replace approach. It's a piecemeal approach, and again, keep in mind that in many cases 4G networks are good enough for majority of the use cases.
Right.
However, what we are seeing and what we believe the operators should be doing is that introduce some components of 5G. In fact, 5G non-standalone architectures calls for the same thing. Essentially introduce a few pieces, modernize some of these networks, and then modernize some of the supporting components to kind of go hand in hand with this modernization on the RAN side, or the so-called radio side. That's where we come in picture, companies like us come in picture, that our Thunder CFW gives that path to modernize the existing networks without adding a lot of costs. The additional advantage for us and for many other companies for that matter is that the telcos can modernize some of these networks and they can reap the benefits of this modernization today while they are getting ready for 5G. So one of the interesting terms we are seeing emerging is the so-called 5G ready rather than 5G. As you know, that spectrum has not been sold in many countries and many regions.
Right.
So telcos just can't launch the 5G right now, but they are getting ready for 5G, and that's where they are getting ready their network for that as well. Modernizing their network, making sure it's virtualized, making sure it's agile, all of those things.
So how does a mobile operator handle the subscriber demands as more almost every mobile network around the world is growing subscribers?
Right.
So what can they do to sort of handle that demand as they're modernizing?
Right. I think cost becomes a critical factor in that. And as we all know that ARPU is going down significantly and cost of operations is going up. So how to kind of make sense out of this and what to do and what's the strategy over there? One of the things which we believe can happen is, or should happen, is that the mobile operators should combine some of these functions. And let me take a step back. In 4G and 3G networks, these networks were built over time in a piecemeal fashion.
Right.
What does that mean? Back in the day, there was so-called caching and those sort of optimization services. So some components were added to serve those use cases. Then security was added. Then with IPv4 address depletion, CGNAT was introduced. So there's built up in a layers. And that means that they have to, and so in some cases these layers were from different vendors. So now telcos have to operate different disparate components from different vendors. And there is an opportunity in 5G when they're redesigning the networks to consolidate some of these items. That will reduce the CapEx and that will reduce the OpEx. It's a one-time investment in one component which serves 2 or 3 use cases. And then on top of that, it's easy to operate, it's easy to maintain, it's easy to upgrade as well, and it's easy to keep an eye on, and training-wise, it's the same component as well. So consolidation, in our view, is one of the critical components here. And that's why in our Thunder CFW product line, we're really focusing on combining some of these use cases. Firewall with CGNAT, with the visibility, and with intelligent traffic steering, and security as well. So all of these things combined in a single function, in physical or virtual side, that will keep tabs on cost, and that will reduce the CapEx and OpEx significantly for the telcos.
Since you bring up some security-related technologies, how do operators balance this I guess trade-off between higher performance network, more bandwidth, faster speeds, and wanting to maintain the safety and security that they're known for? Right.
Well, the traditional ways of security may not scale too much in the current or the upcoming environments. Right. In 5G, understand that every smartphone can be compromised and it can be turned into a potential weapon. And now the challenge is that these weapons are on the inside of the network, and they can start attacking the core of the network itself. These are the things which were not thought of earlier. Now what does that mean? That the operators now need to be cognizant of these things, and to cope with these new threats, these new attack vectors, they need to really invest a bit more on security. Now how do they do that? The traditional way of security was to protect their their edge infrastructure from attacks coming in from the internet,
right,
either through a GI, SGI firewall, or through anti-DDoS machine or a component there. Increasingly, we are seeing attacks are coming in from the inside of the network. We have seen botnets like WireX and so many others who compromised the cell phones, and they started attacking hosts on the outside of the network. Then we are seeing attacks coming in from the partner networks, the so-called GRX, IPX networks. So the service providers have to kind of add more security to their entire network. It has to be kind of holistic approach, not only the GI, SGI firewall, but also the roaming firewalls, and then increasingly anti-DDoS on the internet side as well as on the inside of the network. That is where new technologies come in picture. In our case, we have put in machine learning based algorithms in our data plane to detect any attack coming in from any of these interfaces, and then we can detect and automatically mitigate some of these attacks. That is where we have products which are shipping today, and we believe that it will provide the security at a fraction of a cost, because we are inline, we are on data plane, and we can see all the traffic rather than we are not doing any sampling. So these are some of the ways they can protect their networks.
Yeah, you're talking about too the challenge, changes because the attack vectors change, the technology has to mature on that, and the network monitoring, I guess, has to change as well. So how does network monitoring and the analytics data that you take from the network,
right,
how does that sort of that process change as you get into 5G?
Yeah, well, analytics are becoming much more important in 5G. In 4G it was important, but in 5G it's going to be much more important.
Yeah.
Mean time to resolution is one of the important use cases which are the current analytics is trying to solve that. Now, how would that change? Getting analytics and distilling analytics at source or near source is much more important. That means that every machine in the path and as closer to the source as possible, in this case mobile phones, those machines need to start generating these analytics. Also, increasingly analytics should not be a sample-based approach. It should be taken or viewed as something which is inline, which is seeing all the traffic going through the network, and based on that taking reactive and preventive measures. Now, analytics from our standpoint, from A10 standpoint, we are focusing much more on today's use cases, which are the mean time to resolution and getting better visibility into the network and the health of the network. And that is where, in our case, since our analytics are built into the network, built into the data plane, we can create those at scale, and more importantly, we do not need to export some of these analytics. We can distill it at source and create meaningful actions out of that, and just send out the actions rather than sending out the entire raw data. And that is where the power of vertical integration come in. vertical integrated solution compared to a piecemeal solution from different vendors. There's a lot of difference in that.
So what has A10 learned as it's been involved in 5G deployments so far?
Right. So we were one of the first ones to win some of these critical projects and critical design wins in some of the so-called trailblazers in APAC, in Japan and Korea. And we are chosen by some of these very early adopters. When we went in these POCs, and that was back in 2016 and 2017, we realized and the operators realized that the 5G traffic is much more different than the 4G traffic. 4G was all about throughput, was all about scale, but in terms of throughput. And then in 5G, when it comes to massive IoT, for example, it's no longer about throughput. It's about small packets, multiple connections, multiple simultaneous connections, and new hundreds and thousands of new connections coming in per second. And then again, let me explain what I mean by that. Yeah. In 4G and 3G and in the current use cases is again more like entertainment purposes. Majority of the use cases are entertainment, people watching YouTube. So it's basically large packets, a few of these connections, large packets, and a stream of video. In 5G, it's going to be massive IoT, a smart meter or something sending one connection out or one packet out with a few bytes of data. But more importantly, the number of IoTs are exploding. Every light bulb in your house, every thermostat button, and all of those things could be IoT. That means that instead of having 2 or 3 cell phones per household, you now have 100 or so IoTs and a few cell phones as well. All of these IoTs are creating tremendous pressure on the number of new connections, even if it's for a few packets or a few seconds, but a connection coming in and going off. So not only throughput is important, but also simultaneous sessions, or we call it concurrent sessions, and new connections coming in every second, and we call it that CPS, connections per second. Right. So that is what we learned in these early trials, that networks which are designed for throughput were not able to cope with these new demands of the network. And that is where we won many of these POCs. A10's devices are not built around ASICs, which are good for throughput but not good for CPS and through CPS. I mean concurrent sessions and CPS. We are built from the ground up on CPU-based analysis, and because of that, we can handle much more CPS, and we can handle many millions of more simultaneous connections compared to our competitors. So these were some of the early learnings.
Yeah. Fantastic. This is really interesting, especially as this stuff evolves, and we'll definitely keep in touch as we find out more about these deployments as they go commercial and go live in multiple areas. Yasir, thanks so much for being here. I appreciate it.
Thank you, Phil. Yeah.